In this video tutorial, we are going to cover some problems related to perimeter and area. So the first problem is, through a rectangular field of length 90 meter and breadth 60 meter, two roads are constructed which are parallel to the sides and cut each other at right angles through the center of the field. Okay, so the first information is we have a rectangular field of length 90 meter and breadth 60 meter. Let's draw that. So this is a rectangular field. This one. So it's not very straight. That's better, right? Okay. So A, B, C and D. This is our rectangular field. Length is 90 meter. Breadth is 60 meter. Now, two roads are constructed which are parallel to the sides. So two roads are constructed which are parallel to the sides. So one road will be parallel to this side, that is length, and another road will be parallel to this side, that is direction will be in this way, orientation will be in this way, and cut each other at right angles through the center of the field. And that makes sense. If one road is parallel to the length and another road is parallel to the breadth, then of course they will cut at 90 degree because these two sides are actually at 90 degree. So let's draw that. So this is road 1 and they pass through the center, that's given. They pass through the center if the width of each road is 3 meter. Each road is of width 3 meter. So this is our road 1 and let's do this. This is road 1 and from the center passes the next road, that is this one, that is this one. So this is the second road. Now it's given that these two roads are actually 3 meter wide. This is 3 meter wide. The width is 3 meter and even its width is 3 meter, right? So the area covered by the roads. Find the area covered by the roads. Now, if you look at this road, clearly the length of this road will be 90 meter, right? And the breadth of or the width of this road will be, let's name it road 1. So for road 1, length will be 90 meter and breadth will be 3 meter. Then for road 2, length will be this 60 meter and breadth will be 3 meter. Now here it's asking find the area covered by the roads. If you find the area of this road 1, if we denote this with A1 area, and for this A2, let's calculate for A1. So A1 is what? A1 is L times B, that is 90 meter times 3 meter, and you get 270 meters square, and if you solve for A2, you get 60 meter times 3 meter is equal to 180 meter square, right? So A1 is 270 meters square and A2 is 180 meters square. Now if you add these two area, right, that is A1 plus A2, you get the area of road 1 plus area of road 2, and that's what it's asking here, right? A1 plus A2, that is 270 meters square plus 180 meters square. But here is the thing, first you add them, 350 and this is 450 meters square, right? 270 plus 80, 350 plus 100, 450 meters square. Here is the thing, when you look at this crossing of the roads, then you can clearly see that actually one area, that is this much, this area, or let me take with some different color, this area, this much area is actually common. This area is common, right? This is common. So you have to subtract the area of this much from this 450 meters square, right? First let's calculate and then I'll explain you why we are doing this, because most of the students get confused in this. So what's the this side? Of course this is 3 meter, right? This is 3 meter. This is 3 meter, therefore this is also 3 meter, and this is also 3 meter, and this is also 3 meter, right? Now clearly it's a square, and area of the square is what? A times A, right? A, that is side times side. So in this case it's 3 times 3, that gives us 9 meter square. Subtract from this 9 meter square, you get 441 meter square. Now if there is any confusion, let me remove that. So when you look at this one, when you look at this road, right? So this is your rectangular field, and we take this road, okay, this sort of diagram. Now you can clearly see that you have actually already covered this entire path. Now if I try to build the second road, right, if you find the area of this one, that is A1, you are actually calculating the complete area that is shaded here. And if I try to now build the second road from here, clearly it's passing through this region, and this area, this particular area has already been calculated in this A1, right? So we cannot calculate two times. This area has already been calculated in A1, right? You can again see this, I'm removing it. This road that's covering this region has already been calculated or covered when we were calculating area for this road one. That's why we are subtracting one time from the total area, because one time if you subtract, then it means that you are subtracting the area that's being covered by the second road again, right? So that was a common. That's why we subtracted, and the area covered by the roads will be 441 meters square. Now, in the second part, the question is asking find the cost of constructing the roads at the rate of rupees 110 meter per square. The rate is given 110 per meter square. For 1 meter square, rate is rupees 110. Therefore, for 441 meter square, rate will be how much? Rupees 110 times 441. And if you multiply it, this comes as 441 times 11. This gives you 144,144,1584. So this is 4 rupees 4,800 4851 and 10 we have left here while we were calculating this product. So put 0 here. We left this just to avoid one increased step in calculation. So rupees 48,510. This will be the cost of the construction for this two complete roads at a rate of rupees 110 per meter square. Now let's move this to this problem. Pragya wrapped a cord around a circular pipe of radius 4 cm and then cut off the length required of the cord. Then she wrapped it around a square box of side 4 cm. Did she have any cord left? So if we look at, let's suppose that this is the top view of circular pipe. Let's say that this is the top view, not very perfect diagram, but just assume for our discussion that it's a perfect circle, right? So the radius of this circular pipe is how much? Is 4 cm. Is 4 cm. It's a top view. Okay, it's a superior view of the circular pipe. Now, if Pragya wrap a cord around it, so she starts wrapping from this point. She wraps. Okay, she wraps the cord. She wraps, and so this was the extra part. She cuts from this point. That is cut. Now she takes this wrapped or the left off cord that was wrapped around this circular pipe. Let's say that this is this much. So can you tell the length of this wrapped cord that has been cut off from the full cord? So exactly you can tell the length of this cord that was wrapped around this circular pipe, and that will be the circumference of this circular pipe. The circumference of this circular pipe will be how much? Will be 2 pi r. Even though that is a pipe, right? But its outer surface is actually what? Is a circle. So when she wraps around this pipe, she's actually wrapping around a circle. So circumference of this circle will give the length of the cord that has been wrapped around this circular pipe. So length will be how much? The length of this cord will be how much? 2 pi and r, that is the radius. So 2 times pi is how much? 3.14 times what's the radius? Radius is 4 cm. So you get 8 times 3.14 centimeter, and if you calculate it, you get 8 times 432, 38111, 25.12 centimeter. This is the length of the cord that has been wrapped around this circular pipe. Now, she takes this cord, the cut off cord, and she wraps it around a square box of side 4 centimeter. So imagine that this is your square box. The top view of the square box is this one. This is a top view because clearly a box is actually a 3D thing, because it will have length, it will have breadth, and it will have a height. So this is actually a top view. This is, you're looking from the top. So top view will appear like this, a perfect square, right? You can imagine any square box in your mind and just imagine that you are viewing it from the top, portion. So now if you take this cord and if you wrap it around, that's what is asking, did she have any cord left if you completely wrap it around this square box? So the sides of the square box are 4 centimeter. The sides are 4 centimeter. So this is 4 centimeter. This is 4 centimeter. This is 4 centimeter. And this is also 4 centimeter. Clearly, you also calculate the perimeter of this square. The perimeter of this square. So perimeter is actually what? 4 times side, right? Because side plus side plus side plus side will give you the perimeter, that is 4 times side. All sides are equal. So 4 times 4 centimeter, this gives you 16 centimeter, right? So it means that when you wrap this cord around this square box, suppose you start from here, you wrap it around, and then again you wrap it around. So the length that you will use in wrapping around the square box will be how much? 16 centimeter. Now clearly the total length of this cord that was cut off is 25.12 centimeter, and you are only required 16 centimeter if you have to wrap it around this square box. So what's the remaining length? Clearly 25.12 centimeter, right, minus 16 centimeter, that is 0 centimeter. If you want to calculate it, you can calculate. So this 2, this is 1, this gives you 9.12 centimeter. 25.12 centimeter minus 16 centimeter gives you 9.12 centimeter. This is the length that will remain left if you wrap it around the square box, right? Next problem. Find the area of the shaded portions. Okay, so first one is this and second one is this. Let's solve for this one. In this diagram, you can clearly see that this is actually a rectangle. Why? This is 10, AE is 10, AE is 10, and plus EB is 8, that is 10 centimeter plus 8 centimeter. This is AB. If you add these two, you get AB is equal to 18 centimeter. So AB is 18 centimeter and CD is also 18 centimeter, right? That is the length. And here BC is 10 centimeter, and if you add this AD is what? Actually AF plus FT is equal to 6 centimeter plus 4 centimeter, you get 10 centimeter. That is 10 centimeter here, 10 centimeter here. This is what? This is breadth. Now you have to calculate the shaded portion, area of this shaded portion. How to do this? That's very simple. You can look at this figure, this portion, that is triangle BEC, triangle, let's name it triangle 1, triangle 1. So in triangle 1 you have triangle BEC, and this is what? BE is 8, BE is 8 centimeter, and BC is 10 centimeter. Now clearly this BC is actually what? Is actually, if you look at this figure, then you can take either this one, since this is a right angle triangle, clearly it's right angled here, right? At vertex B it is right angle. Now you can either take this one as the base and this one as the height, or you can take this one as the base and this side as the height. Doesn't matter which you want to take. You have to calculate actually area. You can take this as the base or this as the base, and therefore corresponding heights. So what I'm doing is I'm going to take this one as the height and this one as the base. So if BC is the base, we can calculate the area. Area of triangle BEC will be half times base. I'm considering this as a base, that is 10 centimeter, times this as a height, that is 8 centimeter. So you get, this is 5 centimeter times 8 centimeter, you get 40 centimeter square. So let's name it A1. That's area of this one is A1. A1 comes as 40 centimeter square. In the same way, if we take this as the triangle 2, so in 2, triangle AFE or EAF, because it's right angle at A, so let's name it triangle EAF. In triangle EAF, right angle is at A, so again I'm assuming that this AF as the base and AE as the height. Doesn't matter which side you choose as a base and height, the answer will come the same because this is the right angle triangle. So in EAF we have AE, that is 10 centimeter, and AF, that is 6 centimeter. Now if we denote this with A2, that is area, is equal to half times base times height is equal to half. Let us take this as a base, AE, or even this as a base, whichever we want to take. I'm taking this AE as a base. So base is 10 centimeter times what's the height is 6 centimeter, and you get 30 centimeter square. So A1 is 40 centimeter square and A2 is 30 centimeter square. Now if I try to find out the area of this whole rectangle, right? So let's name it A3, area of whole rectangle. A3, area of rectangle. This comes as length times breadth. What's the length? Length is 18 times what's the breadth is 10. Sorry, let us put the unit. 18 centimeter times 10 centimeter, and you get 180 centimeter square. So A3 is what? 180 centimeter square. If A3 is 180 centimeter square, and from this area, that is from this complete area, if we subtract the sum of these two areas, that is A3, right, minus A1 plus A2. If you add A1 and A2, that is area of this triangle plus area of this triangle, and then you subtract the sum from the whole, you will get actually what? This shaded portion. That's what we have to do. So what's A3? A3 is 180 centimeter square minus what's A1 plus A2? A1 is 40 centimeter square, A2 is 30 centimeter square. This comes as 70 centimeter square, and if you subtract this, you get 110 centimeter square. Okay. For this one, in this figure, QR is 20, right? And if you look at this one, this is actually RU plus US. RU plus US is what? RS. So RS is equal to RU plus US, and this is what? 10 centimeter plus 10 centimeter, and is equal to 20 centimeter. Now clearly this is 20 centimeter, this is 20 centimeter, right? And all these are actually at right angle only. If we look at the figure, these are actually at right angle. So if this is 20, then of course this also has to be 20, right? Because all are at right angle, all are at parallel, opposite sides are parallel to each other and equal to each other. That makes it a square. So if RS is 20 centimeter, then QP or PQ will also have to be 20 centimeter, right? Equal to this one. So from this, RS is 20 centimeter, therefore all the sides are parallel and therefore are at right angle, therefore it's actually a square only. So RS is 20, so PQ, therefore PQ is also 20 centimeter. Okay. Now QR is 20 centimeter. Therefore, PS will also be 20 centimeter. PS will also be 20 centimeter. Now since ST is how much? 10 centimeter. Therefore, this PT will be what? PT will be PS, that is complete PS minus TS. PS minus TS. This gives you what? This gives you 20 centimeter minus 10 centimeter. And you get what? 10 centimeter. These steps are really very important when you are writing examination, because in examination you have to explain all the steps very clearly if you want to get good marks. So this is 10, and from here we also get that this one also be 10 centimeter. Now if you look at this figure, then you are here, just as we did in this case, you can look at this figure, then you'll find triangle 1, triangle 2 and triangle 3, right? Triangle 1, triangle 2 and triangle 3. So if you first find out the area of the square, and then from that area if you subtract the area of this triangle plus this triangle plus this triangle, then you get the area of this shaded portion. I am repeating again, area of the square minus area of this triangle plus this triangle plus this triangle. That is the sum of the areas of these three triangles from the area of the square. If you find it out, you'll get the area of this shaded portion, right? So let's do this. What is the area of the square? I'm removing all these things. Area of the square is actually A square. Area of square, let's name it A1, will be A square, A times A, that is side times side. So in this case this is 20 centimeter times 20 centimeter, and you get as 400 centimeter square. So A1 comes as 400 centimeter square. Now in this figure, let's calculate A1. A1, that is area of triangle A1, is equal to half times base times height. This is right angle at S. So I'm taking this as the base. So this gives you half times base is 10 centimeter times height is also 10 centimeter. And if you solve it, you get A1 as 50 centimeter square. Now let's do for A2. So area of triangle 2 is equal to half times, let's take this as a base, 10 centimeter times, let's take this as the height, 20 centimeter, and you get A2 as 100 centimeter square. Now let's calculate A3. Let's calculate A3. Half times, let's take this as the base, so 10 centimeter. I'm repeating again, you can either take this one as a base or this one as the base, this one as a base or this one as the base. In right angle triangle you are going to get the same answer. Half times 10 centimeter times height is what? This is 20, this whole 20 centimeter. So this 20 centimeter, and if you solve it, you get A3 as 100 centimeter square. Okay. Now A1 plus A2 plus A3. What will be that? A1 plus A2 plus A3 will be 100 plus 100 is 200, 250 centimeter square. 250 centimeter square. Subtract 250 centimeter square from 400 centimeter square and you get what? You get 150 centimeter square, and that is the area of this shaded portion. This is the last problem. AC is 22 centimeter, that is from here to here. AC is 22 centimeter. BM, that is perpendicular on this AC, is 3 centimeter. DN, that is perpendicular to AC, that's given here, is also 3 centimeter. So this is 3 centimeter and this is also 3 centimeter. And this AC is 22 centimeter. Find the area of the quadrilateral ABCD. Area of the quadrilateral ABCD. Now you can clearly see that. Let me do this. Here you can actually see that this is the height and AC as the base, and you can find two triangles. Let me first quickly highlight this triangle 1. So this is a triangle 1. This is a triangle 1. Calculate this area. So for area 1, for area 1, half times base times height, this comes as half times, what's the base here? Clearly AC. What's the height here? That's a perpendicular, that's BM. So this is half times AC is how much? 22 centimeter times what's BM? That's 3 centimeter. So you get 33 centimeter square. A1 is 33 centimeter square. Now let us quickly highlight the second triangle, that's this one. So triangle A2 is half times, what's base? AC. What's height? That is this perpendicular on the base, that is DN. Half times, what's AC? 22 centimeter. What's the DN? That is 3 centimeter. This comes as same, that is 33 centimeter square. So A2 is 33 centimeter square. So if you add A1 plus A2, you get 66 centimeter square. That is this area plus this area, that's the area of the quadrilateral. So area of the quadrilateral is how much? 66 centimeter square.